Salam, our session today is about limits and asymptote. Let's just make a quick revision about asymptotes. If limit as x tends a number a of a function f of x equal infinity, then we have x equal a vertical asymptote. Vertical asymptote. We did explain this in class. And if limit as x tends infinity of a function equal a number b, then y equal b horizontal asymptote. If limit as x tends infinity equal infinity, it might be an oblique asymptote. We didn't explain it yet. And if limit as x tends a number equal number, we have something that we call a limit point. We don't have an asymptote. So for each of the following function, we have to calculate the limits and determine if we have asymptotes or not. I will start by part 1, f of x equal 2x plus 1 over x. At first we have to calculate the limits. Before calculating the limits, I should determine the domain of definition, because I calculate the limits at the open bounds of the domain of definition. So I should say that x is not equal to 0. The domain of definition will be minus infinity 0 union with 0 plus infinity. Calculating the limit as x tends minus infinity of the function f of x equal limit as x tends minus infinity of when you calculate the limit at infinity of a fraction, you take the term fraction with polynomials in the numerator and the denominator. You take the term with the highest degree in the numerator and the term with the highest degree in the denominator. You do simplify by x and the answer is 2. Limit at infinity equal 2, so y equal 2 horizontal asymptote. As the same, if you did calculate limit as x tends plus infinity of f of x, you will obtain also 2 using the same method, so y equal to horizontal asymptote. Now limit as x tends to 0. We have limit at 0 minus and 0 limit at 0 plus. This is at 0 minus 0 plus. Limit as x tends 0 minus of f of x. You just replace x by 0. 2 times 0 plus 1 is 1 over 0 minus. Number over 0 is infinity, plus over minus is negative, minus infinity. Limit as x tends a number equal infinity, so x equal a 0 vertical asymptote. Also limit as x tends 0 plus of the function f of x. Using the same way, you will obtain plus infinity, so also x equals 0 vertical asymptote. We wrote it 1, we don't have to write it again. Part 2. If you have the function f of x equal 3x minus 1 over x plus 2, and we need to find the asymptote, so we need at first to calculate the domain. X plus 2 not equal to 0, then x not equal to minus 2. The domain will be minus infinity minus 2 union with minus 2 plus infinity. This is at first. Second, we should calculate the limits. Limit as x tends minus infinity of f of x equal limit as x tends minus infinity of 3x over x, and the answer is 3, so y equal 3 horizontal asymptote. Plus infinity is the same, so I'm gonna put here plus minus or plus infinity, minus or plus infinity is the same. Now limit as x tends minus 2 minus limit as x tends minus 2 minus of f of x equal 3 times minus 2 minus 6 minus 1 7 over minus 2 plus 2 0. We have to determine whether it's 0 plus or 0 minus. Using the sign table of the denominator, you find it's a 0 minus. Negative over negative is positive, number over 0 infinity. X tends to minus 2 is infinity, so x equal minus 2 vertical asymptote. Using the same way, at minus 2 plus, you will obtain minus infinity, and you obtain x equal minus 2 vertical asymptote. So these are the first two parts. These are the first two parts. Now, and they are easy, as you can see. Part 3, limit it's not limit. As first I should write the function f of x equal 3 over x minus 2. So the domain of definition is of course x not equal to 2 minus infinity 2 union with 2 plus infinity. A limit as x tends minus infinity of the function f of x. You just replace x by minus infinity minus 2 minus infinity equal to 0. Infinity is 0, so y equals 0 at shape. At plus infinity is going to be the same, so I'm gonna write it in one sentence, one operation. Limit as x tends 2 minus of the function f of x. You just replace x by 2. 3 over 2 minus 2, 0. Using the sign table is 0 minus, so it's minus infinity. X equal 2 vertical asymptote. Limit as x tends to plus. Doing the same, you will obtain plus infinity. Part 4 is as the same as part 1 and 2, nothing different. I'm not going to solve it. Part 5, f of x equal x squared plus 1 over x squared minus 4. Firstly, to determine the domain of definition, you should say it's not equal to 0. You can solve it using delta, or x squared not equal to 4, x not equal to 2, or x not equal to minus 2, or using calculator. In all ways you can, in different ways you can solve this quadratic equation. Domain of definition equal minus infinity minus 2 union with minus 2 plus 2 union with 2 plus infinity. We should calculate limit as x tends minus infinity of the function f of x equal limit as x tends minus infinity. In the case of infinity of a fraction, you take the highest degree over the highest degree if the numerator and the denominator are polynomial function. X squared equal 1, at infinity equal 1, so y equal 1. It's a horizontal asymptote. At plus infinity it would be the same, so I'm gonna write minus or plus infinity. Then at minus 2 minus, limit as x tends minus 2 minus of the function f of x equal, you just replace x by minus 2, 5 over 0. You should know if it's a 0 minus or a 0 plus, so you have minus 2 and 2 opposite, same. Why I'm setting up the sign table? Because I need to know at minus 2 minus if it's a 0 minus or a 0 plus. In the previous parts I did it mentally. It was easy because it was the first degree. Minus 2 minus, before minus 2 you have a plus, so it's a 0 plus, and the answer is plus infinity. So x equal minus 2 vertical asymptote. So we always set up the sign table of the denominator just to know if it's a 0 plus or a 0 minus. Limit as x tends minus 2 plus of the function f of x. Doing the same procedure will obtain minus infinity, x equal minus 2 vertical asymptote. Limit as x tends 2 minus of f of x, you just replace x by 2, it's 5 over 0. Before 2 you have a minus, it's negative here, so it's 0 minus, and the answer is minus infinity, so x equal 2 vertical asymptote. Add 2 plus is the same, is plus infinity. That's everything for today. Inshallah tomorrow video is about